Okay, going to look at the hardest kind of differential equations question in the A-level maths. And this is one of those where you have to form the equation yourself, very often with a tank of water like there is in this question. Okay, so we've got a picture. We have all our text just describing the picture basically. So the water is flowing into the tank at a constant rate. The tank is cuboid, it's got the side lengths. Negligible thickness, it just means that the volume of the tank is 3 times 8 times 5. It's not, there's some thickness of the walls and it's slightly less. And there is a tap at point T. And what we know is that we're going to call the depth or the height of the water H. And water is flowing into the tank, like mentioned, at this constant rate there. And water is flowing out of the tank at this rate. It's not a constant rate, it depends on H. And the question part A is just to show that this equation is true. Okay, now, this equation involves dH by dt and it involves H. So, do I know what dH by dt is from the question? It doesn't tell me this. What it tells me is dV by dt, where V is the volume of water in the tank. Okay, the reason is it's telling me how fast water is flowing into the tank and how fast water is flowing out of the tank. That's going to be the rate of change of volume, right? So dH by dt is the rate of change of height. dV by dt would be the rate of change of volume, which I know from these 2 bullet points. So I'm going to write let V be the volume of water in the tank. From those 2 bullet points, I know the rate of change of this volume, well, it's coming in at 0.48, that's positive 0.48, and water is leaving the tank at this rate, so that's a negative gradient or a negative rate of change because it's decreasing, right? So that's negative 0.1h. So what I have is a nice equation involving h, but the problem is that it involves dV by dt. And what I want is an equation involving dH by dt. And just a quick note on this, when you're looking at what you have and what you need, don't be bogged down with the numbers. So don't be thinking, how am I going to make 1200 appear here? Think about the structure. The structure is of a dH by dt in this equation, and there's not one in this equation. That's what you need to make appear. And the way to do this is when you need to link together your variables. This is actually from the differentiation chapter in the Year 2 textbook. So V is the volume of water in the tank. And you can actually relate V to H because the volume of water is given by 3 times 8 times H. So V is 24H, 3 times 8 times H. This is very helpful. So how am I going to dH by dt? Well, start by writing it, since this is what I want. And you need to do the chain rule here. And you need to involve a V somehow, because I have V. I have dV by dt, so that's going to be useful for us. And the way you can do this is you do the chain rule. Now the chain rule, I introduce a dV. The chain rule just says that derivatives behave like fractions. That's all it's saying, right? It's saying that this is like fractions cancelling off, and this is actually the same thing. So all I had to do, I know I want a fraction that makes dH by dt, and I know I have a V somewhere. That's how I knew I had to stick a dV in the bottom. And then I know I want my overall fraction to still be dH by dt. So to make this work with fraction cancellation, it would have to be a dV on top to cancel them, and a dt on the bottom to finish it off. So that's how I know to get this equation here, where I get dV by dt. Where I get dH by dt is dH by dV times dV by dt. Okay, get rid of all that. And it's good because dH by dt is what I want, dV by dt I have, I just need dH by dV. I just need this. And I know how H and V are linked, they're over here. So you could rearrange for H. You can also, and depending on the situation, it might be easy to do this. You can actually just differentiate normally. So I know V in terms of H, so I do dV by dH, give me 24. And then you can just use the fact that we know this with inverse functions from differentiation chapter. You can just flip upside down, you can flip the derivative upside down. And just make sure you flip the fraction upside down as well. So this is actually fine to do, right? We know this. So dH by dt is given by dH by dV, which is 1 over 24. And dV by dt was up top. And now what I have is an equation involving h and dh by dt, which is exactly what I needed. So I know I'm on the right track. I just need to make these numbers appear. So let's just simplify, right? So use a calculator. So this would give you 1 over 50. I'm expanding it out. This would give you 1 over 240 h. And then, I mean, you can look and see that the 1200 over here. You could combine these, make a common denominator, do whatever you want. I will times both sides by 1200 because I can see what I'm aiming for has a 1200 on the left. And again, just use my calculator to do all these fractions. I get 1200 dh by dt equals 1200 over 50 is 24, 1200 over 240 is 5, and oh, we're all done as required. So I've done part A, got all my marks, I showed the equation. The whole topic on differential equations is now, the rest of it is what we're doing, we're just solving the equation, right? We know how to solve them, we've made our equation, we're going to solve it. So part B says, show that according to model H is this. This has now been solved. I have an expression for H in terms of T, like we mentioned in the last video. So let's solve the equation. So 1200 dh by dt is 24 minus 5h. I need to determine if this is an easy question where I just have everything in terms of t and I just integrate. Well, that's not the case, right? There's a h. So it's going to have to be a separation of variables. I said in the last video, you need to make sure all your h's are on one side to do the separation of variables. Adding over the 5h is not going to be any good. Okay. This is not separation of variables. I can't now separate out my dt by multiplying it up. Right, you get a 5h dt plus 1200 dh equals 24 dt. This is not any good. Okay. You need to get your h's onto one side by dividing, like I said last time. I'm going to divide both sides by the whole right hand side, 24 minus 5h. And multiply both sides by dt. So when I divide by that, I get 1. So I just get 1 dt. You could move the 1200 down if you want to, but there's no need. Okay. I've now separated my variables, all the h's on one side, all the t's on the other side. Let's integrate. So I can just stick an equal sign on both. Now the question boils down to, can you integrate? The left side, it might look scary. It's just one of these f of ax plus b's. Right, if you think of 24 minus 5h as just being your ax plus b, this is essentially just 1 over x or 1 over h, which I know is ln. Okay? So left hand side is going to be, the 1200 is going to stay as it is, just multiplying, right? A factor, constant factor. I'm going to get natural log, I guess I should do an absolute value. And then because it's the f of ax plus b, or by a reverse chain rule, or by anything you want, there's a minus 5 here. I need to divide by that minus 5. Equals, so the integral of 1 dt is t, and then there is a constant c. And I find that c by using my information in the question. Now, let's have a look. Like I said last time, in these differential equation questions, you will often just not really worry about the absolute value. If h was 5, it would be kind of an issue, because, you know, when h is 5, we do have to use that. We get ln negative 1. We're just going to happily ignore them and just deal with the question. Okay, so ln 24 minus 5h times by 1200 over negative 5 is negative 240 equals t plus c. And let's get h by itself because that's what we're going for. Okay. Well, I guess I will first divide by that negative 240. It's negative t over 240. Now the c over negative 240 is it's still just a constant, right? I could just call it c. I'll call it d, a different letter. But I don't have to keep writing c over 240. It's just some constant. It's not going to make a difference. Okay. Exponentiate both sides to get rid of that ln on the left. So I get 24 minus 5h is equal to, now last trick from last time as well, e to the minus t over 240 plus d is the same as e to the minus t over 40 times e to the d, using index laws, and then e to the d is just going to be some constant. I'll call it a. So I get a e to the negative t over 240. And then I can sort of finally, well, I could rearrange for h, or I could find a. Let's find a first, why not? I need to use the initial information in the question. So given that when the tap was opened, the depth was 2 meters. Okay, so what does that tell me? When the tap was opened, the depth was 2 meters. Well, t is the time after the tap was opened. So when t is 0, the depth, which was h, was 2. I'm going to use that. T0, h2. And T0, h was 2. So 24 minus 5 times 2 is 10. This is why I didn't worry about the absolute value, because almost all the values of h here, h is going to be less than 24 over 5. This thing's going to be positive anyway. So 24 minus 10 equals a e. Now, well, when t is 0, this is just e to the 0. It's just 1, isn't it? So I can actually just cross it out. A times 1. So a is 14. So 24 minus 5h is 14 e to the minus t over 240, which means that h, if I rearrange everything correctly, so I'm going to add the 5h over, subtract and divide by 5. So 24 over 5 minus 14 over 5 e to the minus t over 240. Is that kind of in the form that it's asking for? A plus b e to the negative kt. Alright, the answer we got here, it was 24 over 5 minus 14 over 5. And it says e to the negative kt, so I'll write it like that. That's e to the negative, not t over 240, but 1 over 240t. So I can say that k was 1 over 240. A was 24 over 5, and b was 14, or negative 14. Okay. Cool. There's my answer for B. Got my answer for H. Part C, given that the tap remains open, determine whether the tank will ever become full. Okay, so we're sort of asking, what value of H can I get? What's the limit here according to this? And you could look at the expression and analyze it. That's one method. If you did this method, what you would find is that, well, the 24 over 5 is just always 24 over 5. And this term here, well, it's always, well, this number is always positive. E to anything is positive. So this whole term is always negative. So H is 24 over 5, take away something positive. So H is always going to be less than 24 over 5. And 24 over 5, by the way, 4.8 meters. So H is never more than 4.8 meters. So the tank, 5 meters in total, is never going to be full. It's sort of capped at 4.8. So that's one method of answering part C. You say no, because it's capped at 4.8 meters. So for all values of time, the height is less than 4.8. And you kind of need to write this for your answer, but when I say the second method, this might be a little bit tricky. One thing you could consider sometimes is just consider the limit as t goes to infinity. So this was my equation. And you say, as t goes to infinity, what happens to h? Well, 24 over 5 is still 24 over 5. And then this bit, that's e to the negative t, which we know e to the negative t is something that goes to 0 as t goes to infinity, which is minus 0. So this sort of also explains that the limit is 24 over 5, but you do have to justify, well, what if the height goes really big and then it dips down to 24/5? So you do need a full explanation in red over here. The fact that this term's always positive, so you're actually never going to be more than 24/5. If you want to visualize this and sketch it out, which it doesn't ask you to do, but it might help you, h is a constant 24/5 minus a number which is always positive. So this is going to be 24/5. This is actually going to be a horizontal asymptote if you graph it all out. When t is 0, h was 2. It starts at 2. And it's going to go like this forever. I'll try to do that better. It's going to be like that. That's kind of poor. But if you do it properly, and it's always increasing but never reaching that height. Okay? So hopefully that makes sense. You just need to analyze the terms in the equation and realize that this one is always negative. And that essentially gets you the answer. So that's differential equations pretty much wrapped up. This is the kind of equation where you have to do separation of variables, and then you just have to set up your equation initially. And the way to do that was to relate your two unknowns and then do the chain rule over here, which was kind of the tricky part in my opinion. So let me know any questions about this, and I really hope this makes the topic a lot easier.